My name is Jorge Isaac and my teammate is Isaac Ramirez. So in this video we will going through a general overview of chapter 3 of the book Raspberry Pi Computer by Vision Programming. This is titled Introduction to Python Programming. This chapter is fundamental because it establishes the basic of the language and the hardware interaction we will use for our future computer vision projects. So we start with the technical requirements and understanding Python 3. So the book highlights that Python is a general purpose interpreted high level language. Most importantly, Raspberry Pi OS comes with Python 3 pre-installed, so we are ready to start coding without complex configurations. So to write our code, the chapter introduces the available idles. It mentions the classic idle, but it emphasizes Tony idle, which is the one we will be using. Tony is excellent because it is lightweight, easy to use, and allow us to debug code step by step, which is very useful when working with hardware. So let's continue. So let's start. The author explains two ways of working: the interpreted mode, which is writing directly into the Python terminal. It serves to test quick lines of codes. So here you can see. And script mode. That is, this is what we will do for our assignments. It allows us to save complex logic and run whatever we want. So let's continue. For example, here it prints hello world and some more. So before getting into the wiring, the book makes a mandatory stop at the SciPy ecosystem. Although this specific practice is about LEDs, it is crucial to mention NumPy and Matplotlib. NumPy will be used later to handle multidimensional arrays, which is basically how the computer sees images. And Matplotlib will help us plot data and display the results of our vision algorithms. So you can see here is Matplotlib. So let's start with the programming with GPOs. So here we enter the code of the practice GPO pin programming. The key point in this section is understanding the difference between the numbering codes, GPO board referring to the physical pin number on the board from 1 to 40. GPO BCM refers to the channel number on the Broadcom chip. To avoid confusion, in our initial code we'll be using board mode. So here for example, we turn on and turn off a LED. It blinks, its duration, etc. So here we can see two LEDs and a lot of LEDs. So basically it's the same for the next one. So we arrive at the first practical code, blinking a LED, which is this. Here we import the RPI GPO library. We configure pin 8 as output, and the code uses while true infinite loop where we set the pin to high on. We use time sleep to wait. We set the pin to low. So this creates the basic blinking effect. So later, the chapter teaches us to modulate using functions in the ESOS signal example. Instead of repeating code, we create a function that receives the pin and duration parameters, making program much cleaner and professional. So let's continue with the push button programming. We move from controlling outputs to reading inputs. In this section, we connect a push button. The interesting part here is the configuration of the internal pull-up resistors of the Raspberry Pi. The code sets the pin as in input and constantly checks if the state changes to low or ground. If the press button the program detects, it prints a message in the console allowing us to physically interact with our Python script. Hi, hello, hello, how, hello, hi, hello. So we go to the end of chapter. So in summary, this chapter 3 teaches take us from basic Python theory to direct manipulation of the physical world via GPO's pin. Mastering this is the prerequisite to later being able to turn on lights, move motors, or trigger alarms based on what the camera detects with Vision Computer. So thank you so much and see you in the next practice.